Everybody has textbook? Next slide. Flow of electric charges. First, what is electric? Electricity means what? Electric current, electricity. Any idea? What is electric current, electricity? According to you guys. Flow of current through a conductor. Now, if I tell wherever electricity will flow, current will flow means current will flow. Can current flow in plastic? Can current flow in wood? So these are what insulators, where current cannot pass, but current can pass through a wire which is made up of copper, correct? Or metal, or in human beings also current will pass. So current, electricity means wherever the current is flowing or the electrons are flowing, positive, negative, in a what conductor. Conductor means whichever, if I take metals, human beings, we are all conductors of electricity, water. In water also current will pass. But if I take plastic, fiber, wood, their current will not pass. So electricity means simple, it's a flow of current in the through the conductor. Okay, read. Read.
Flow of electric charges through a conductor. Example, metallic wire is called electric current.
So it's called as electric current. Next.
In a torch, the cells or a battery, when placed in proper order, provides electric current through the bulb to burn. A continuous or closed path of an electric current is called the electric circuit.
So there will be an electric circuit for every electricity passing circuits. Okay. Example, here they are using what? This is a bulb. They are using two in the batteries. Example, here I am using batteries. Here also. Similarly, here they are using battery. So it should be adjusted as like this, minus, positive. Again, for positive, negative should be connected. If you connect positive, positive, it will not work. Then here positive. If you connect like this, there is a circuit happening here. The circuit is cells are here, positive, negative. So positive will come and meet here. Okay, the bulb is here. This is ammeter. Negative will come here, so the bulb will glow. Getting both side positive, positive, both side negative, negative, it will not work. Positive, negative, or negative, positive. If you take, it will work. And your arrangement also should be like that only. If you are taking positive, negative, then you should take positive, negative. If you are taking negative, positive, then you should take negative, positive. Getting? So that's a closed circuit. So only they are saying in a torch, the cells or a battery when placed in proper order. Hang become order placement there is a proper order. That's the order. Proper order provide electric current through the bulb to glow. Then only the bulb will glow. If you provide proper electric current. Next, a continuous and closed path. There should be a continuous and closed path. If the wire is cut marbitte. If I break the wire, will it work? Getting? And the continuous, that means the cells should have power, they should be placed in perfect order. Then there is a continuous flow of current. Now why these all things are working? Why fan is continuously rotating? Why this projector is on? Because continuous flow of current is there. This is also working on current. If 5 minutes voice 5 minutes in raga. Why that is not happening? It's perfect. Because there is a continuous flow of charge. This also is giving continuous flow of charge. Then only this will work. Getting? So a continuous and closed path. So here also a continuous and closed path is there. The path is very perfect. Of an electric current is called an electric circuit. Circuit means this is a circuit that has been prepared, which is working properly. Getting? So an electric circuit means it's a continuous and closed path where all the things perfectly work. That means current will flow continuously without any stop, without any problem. That's called as what? Electric circuit. If the circuit is broken, if I break the circuit, or current if the circuit is broken or the switch is turned off, switch off, the current will stop. So as you turn off the switch, or if current goes, or if the circuit breaks, then what will happen? It will switch off the current going path. Path banna biduತ್ತೆ. Current ಹೋಗಲ್ಲ pass ಆಗಲ್ಲ. Any doubts in electric circuit? Electric circuit, any doubt? Any doubt? Electric current means simple. Flow of electric charges through a conductor. Conductor means metal, copper wire, any wire which where current will pass, or human beings also, or water where current will pass. Flow of electric charges will happen. And electric circuit means it's a closed and closed path where the flow of current is happening in perfect manner. Okay, next. Read.
Electric current is measured as the amount of charge flow through a particular area in a unit time. It is the rate of flow of electric charges.
Now, we keep the measure of the units that we are using. Example, if I use water, we know that how much water we are using, how much gallons of water we are using. Similarly, current, it comes in units. You know, bill cut up, okay, electricity bill. So there will know how much units you have used, how much units you have consumed. Similarly, electric current is measured. It should also be measured, no? Now everything will be measured. Correct? Now you are 10th standard. We are measuring that you are 10th standard. Marks will measure. For 30 marks, you got 25 marks. Similarly, everything measurement will be there. So for electric current, how they will measure means getting how they will measure electric current. Electric current is measured as the amount of charge flowing through a particular area in unit. Means how much charge is flowing through the area, cross section area. ಅದರೊಳಗೆ ಆ ವೈರ್ ಒಳಗೆ ಎಷ್ಟು ಕರೆಂಟ್ ಪಾಸ್ ಆಗತ್ತಿಲ್ವಾ, how much, this is a what commercial place, okay, so how much maximum I can use through that area, how much current is flowing through that area continuously, it will be meter meter. So there you will understand how much current I am using. Okay, so electric current is measured as the amount of charge flowing through a particular area in unit time. It is the rate of flow of electric charges. So how many electric charges I will use, that much will be my units. Convert ಆಗ್ತದೆ. Poor explanation ಕೊಟ್ಟಿಲ್ಲ, that's just a definition. Getting? So electric current how you will measure means ನಾ ಎಷ್ಟು ಯೂಸ್ ಕನ್ಸ್ಯೂಮ್ ಮಾಡ್ತಾನಲ್ಲ ಅಷ್ಟೊಂದು ಯೂನಿಟ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತೈತೆ. Correct? So how much more I will use, that much my consuming will be increasing. Electric current is measured as the amount of electric charge flowing through the particular area in unit time. ಈ ಟೈಮ್ ಒಳಗೆ ನಾ ಎಷ್ಟು ಕನ್ಸ್ಯೂಮ್ ಮಾಡತ್ತೀನಿ ಅಷ್ಟು ಮೀಟರ್ ತಿರುಗ್ತದೆ. That's it. Any doubts? Next please. Back. Read.
In a circuit of metallic wire, electrons constitute the flow of charges. Electrons were unknown during the discovery of electricity. So, electric current was considered as the flow of positive charges, and their direction as the flow was taken as the direction of electric current.
Okay, so whatever electric charges we tell them, electric electron, the word will sit like that. So what they are saying is, in a circuit of metallic wire, whichever wire you take, metallic wire, copper wire, in a circuit of metallic wire, this is a circuit, electrons constitute the flow of charges. So whatever positive or negative you are seeing, those are electrons. Those are not protons, neutrons. Those are what? Electrons. Positive electron, negative electron. Getting? So electrons are the main reason why current is flowing. Electrons constitute the flow of charges. Electrons were unknown during the discovery of electricity. So before, when we knew about electricity, that electricity is there, but we didn't know that it was electrons. They thought it was positive charges flowing. Positive charge vichar ಮಾಡ್ತಿದ್ರು. But in fact it was electrons. After the discovery of electricity, we understood that electrons are also present. ಅಲ್ಲಿ ತನಕ electrons ಐತೆ ಗೊತ್ತೇ ಇರಲ್ಲ. Okay, read next.
So electric current was considered as the flow of positive charges, and their direction as the flow was taken as the direction of electric current.
So electric current was considered as a flow of, they thought it was only positive charge that was coming. Getting? But later on we understood that it had negative charge also, and there are electrons. Charges, and their direction of flow was taken as a direction of electric current. ಈಗ ಎಕಡೆ flow ಆಗ್ತಿರ್ತದೆ direction, that was took as direction of current. Example, here the direction of current is, they have took like this. So the direction of current is like this. You can see throughout the diagram it is going like this. So the direction of current is like this. Getting? This will come in further Fleming's left hand rule, right hand rule. There you will understand more about direction of current. Now it's just basic. Okay, don't concentrate that much. Leave that. Next.
Conventionally, in an electric current,
Circuit.
the direction of electric current is taken as opposite to the direction of the flow of electrons, negative charges. Electric current flows.
Now see, this is the most important thing. Here, these are the things that will make you good in electricity chapter. Conventionally, in an electric circuit, that's an electric circuit. Okay, now you guys will tell where the current will flow. How to identify that? How to identify where current will flow? Here is positive terminal. Here is negative terminal. Okay. So what they are saying, in an electric circuit, the direction of electric current direction. Okay. So direction is like this. The direction of an electric current is taken as opposite to the direction of the flow of electrons, negative terminal. So negative terminal is here. Negative will pass like this current. Yes or no? Negative is passing like this. So you should take opposite of that, it seems. So the direction will be how much? That direction will be like this. Getting? Again, thing is vichar ಮಾಡ್ತೀವಿ. Okay. Here it was negative, here it was positive. This is a circuit you think. Okay, this is a circuit. So it will be like this, left side or right side current. Current will flow at left side or right side according to you guys. Yeah, side. Ankit, right side. Because negative terminal is here means current should actually flow like this, but it will flow ulta of negative terminal. So if negative is here, it will flow through positive. So the direction of current is like this. Here it will go, here, then come back. Getting? So that is how you identify the direction of current by seeing positive and negative terminal. Wherever positive and negative terminal is there, you can tell the direction of current. Okay, this is one rule now. So as I go further, their direction of current will be changing. This one the fix alarm. Okay, so keep updating that. Any doubts still here now? Next, read this.
Electric current flows from positive terminal of the cell to negative terminal.
So always the electric current flows from the positive terminal to the negative terminal. Getting or no? So negative ulta vichar ಮಾಡಿ ಇಲ್ಲ positive terminal start ಆಗುತ್ತೆ ಇವತ್ತಿಗೂ and ends at what negative terminal. Any doubts? Any doubts? Okay. Next. ಏನು ಟೈಮ್ ಅಂದ್ರೆ ಮಕ್ಕೊಂಬಿಟ್ಟಿದ್ದೇನೆ. ನೆಕ್ಸ್ಟ್ ವೆರಿ
Consider a net charge Q flows across cross section of a conductor in time t when current L through a
current is high.
when current I through the cross section is I equals to Q by T.
See here, what is the again you cross section? What is cross section area? Cross section area means what? Cross section area. Any idea? Cross section area means here. If I take a wire, think it is like this. Okay, this is a wire that is going. Cross section area means pura in wire in pura. Not only I should go like this. Not only I should take further. Everything is included. And the one centimeters ಬಿಡಂಗಿಲ್ಲ ಪೂರ ಈಗ ಇದನ್ನ ತಗೊಂಡಿರ್ಬೇಕು. ಇದು ಪೂರ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಅಂದ್ರೆ ಇದ್ರೊಳಗೆ ಎಷ್ಟು ಕರೆಂಟ್ ಪಾಸ್ ಆಕೈತಪ್ಪ ಪೂರ ಇದ್ರ ಒಳಗಡೆ ತಿಳಿತೈತಿ ಫುಲ್. If I take my body as cross section area, ನನ್ನ ಬಾಡಿ ಪೂರ ಎಷ್ಟು ಕರೆಂಟ್ ಹೋಗ್ಬೋದಪ್ಪ full my body is only cross section area like that. Whatever we take, if I take this pen, this full pen is only cross section area pura. So cross section area means the area of this whole wire area. One ಸ್ವಲ್ಪ ಬಿಡಂಗಿಲ್ಲ. That is the meaning of cross section area. Throughout the wire we take. ಈ wire ಒಳಗೆ maximum ಎಷ್ಟು area ಐತಪ್ಪ that will consider here. Okay. Consider a net charge Q. So a Q, this is a charge flowing through this wire. Consider a net charge Q. Q means charge ಅಂದ್ರೆ current pass ಆಕೈತಿ. Charge Q flows across a cross section area of this conductor through time t. From here, it should pass to till here. So it requires time. Charge pass over time ಬೇಕು. मिली सेकेंड्स लोग करते हैं, मिली सेकेंड्स ಈಗ ಅಲ್ಲಿಂದ ಇಲ್ಲಿ ಕರೆಂಟ್ ಬರತ್ತಿದೆ. ಓಕೆ, ಸೊ ಹೌ ಮಚ್ ಫಾಸ್ಟ್ ಇಟ್ ಇಸ್ ಟ್ರಾವೆಲಿಂಗ್, ಥಿಂಕ್. We cannot measure it in even seconds also, milliseconds. But definitely it's passing from there to here. ಕೇಳತ್ತಿಲ್ಲ, ಸ್ಟಾಪ್ ಇಲ್ಲ, ಅದು ಕಂಟಿನ್ಯೂಸ್ಲಿ ಪಾಸಿಂಗ್ ಆಗತ್ತೆ. ಈಗ ಹಿಂಗೆ ಕೊಟ್ಟು ಹಿಂಗೆ ನಿಂತಿರ್ಪ, ಕಂಟಿನ್ಯೂಸ್ಲಿ ದಟ್ಸ್ ಟ್ರಾನ್ಸ್ಫರಿಂಗ್ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್. Getting? So a net charge Q flows across a cross section area of conductor in time t. Then current I, this is a current I through the cross section is I is equal to charge by time. Current is equal to charge upon time, or I is equal to Q by T. Getting? Or Q is equal to IT. Q, if you place it here, charge is equal to current into time. That's the formula. Getting? So this is your first formula. What did we learn here? How do we measure current? How do we measure current? We are speaking still. Current is equal to how much charge is passing. How much charge? ಈಗ ಒಂದ್ಸಲ ಸ್ವಲ್ಪ ಈಗ ವಿಚಾರ ಮಾಡಿದ್ರೆ, here we are using what 22 volts, 220 volts ಇರ್ಬೋದು. Okay. But in other countries, USA or China, if you go to any big country, they're 280 volts, 250 volts. And our cross section area ಜಾಸ್ತಿ ಇರ್ತದೆ. Current will pass more. If current is passing more, getting, then ಏನಾಗ್ತೈತಿ, ಸ್ವಲ್ಪ ಪವರ್ ಜಾಸ್ತಿ ಇದ್ದು ನೀವು ಎಲ್ಲ ಅಪ್ಲಯನ್ಸಸ್ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು, ಆ ಟೈಪ್ ಇರ್ತೈತಿ. ಸೊ current is equal to charge, how much charge is passing by that time. That's how we measure current used. Any doubts? Still here? Okay, next.
SI unit of the electric charge is coulomb.
So SI unit of electric charge is coulomb.
It is equivalent to the charge.
Electric charge under Q. If I measure Q is equal to IT, I will measure it in coulombs. 5 coulomb, 10 coulomb. Q is measured in coulombs. See, Q coulombs. Q is measured in coulombs. Okay. Next.
It is equivalent to the charge contained in the 6 into 10 to the power of 18 electrons.
So 1 coulomb means 6 into 10 power 18 electrons. I got that saying. Read next.
An electron has a negative charge of 1.6 into 10 to the
So
power.
one electron has a negative charge of 1.6 into 10 power minus 19 coulomb. One electron passing will create this much amount of water charge, 1.6 into 10 power minus 19 coulomb. Getting? Next.
SI unit of electric current is ampere.
So electric current ಈಗ ನಾ current is equal to charge by time ಮಾಡಿದ್ರೆ I will measure it in amperes. Current is measured in amperes. Next.
Named after Andre Marie
Ampere, France. Next. Today's class will be little bit what pura theoretical and e type I think. There are too many aspects of what numericals like this. Small numericals. Electricity chapter is, throughout the chapter you will find numericals. I mean like this small 1 ampere under is power. That conversions you should know. ಸ್ವಲ್ಪ ಫಸ್ಟ್ ಟಫ್ ಆಕೈತಿ, ಬಟ್ ಅದು ಕುಂತ ಓದ್ಬೇಕಲ್ಲ, ಅದು ಬೆಟರ್ ಬರಂಗಿಲ್ಲ. ಬಟ್ ಇಫ್ ಯು ಸಿಟ್ ಅಂಡ್ ರೀಡ್ ಯು ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಲ್ ದಿಸ್ ನ್ಯೂಮರಿಕಲ್ಸ್. ಓಕೆ, ರೀಡ್.
1 ampere represents the flow of 1 coulomb of charge per second.
So 1 ampere means 1 charge per 1 charge. 1 ampere represents the flow of 1 coulomb per 1 second. So 1 ampere is equal to coulomb per second. You can think. Why 1 ampere is equal to coulomb per second? Here I is equal to, we write Q by T. Correct? I means what? Ampere. Q means what? Coulomb. Time is measured in seconds. So keep place 1 here. This is what they are saying. 1 ampere means 1 coulomb per 1 second. So that they have written theoretical statement. Next.
Small quantities of current are expressed in milliampere.
Now this you will see in first PUC. When you go to first PUC, you will see this milliampere. So here very small minute current also. Example, the minute current might be from here. Idrolaga ಎಷ್ಟು current pass ಆಗ್ತೈತಿ. If I take it like this, you see here, I'm holding it like this. Now current is flowing through my body or not? According to you guys, it's flowing. But am I getting that feel? ನಂಗೆ ಶಾಕ್ ಹೊಡೆಯತ್ತಿಲ್ಲ, ಬಟ್ ಕರೆಂಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್, ಇಟ್ಸ್ ವೆರಿ ವೆರಿ ಮೈನ್ಯೂಟ್. ಇಫ್ ಐ ಮೇಕ್ ಇಟ್ ಲೈಕ್ ದಿಸ್, ಈಗ ಇನ್ನೂ ಸ್ವಲ್ಪ ಡೇಂಜರ್ ಆಗ್ತದೆ, ಈಗ ಇನ್ನೂ ಜಾಸ್ತಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಬೇಕು. ಇಫ್ ಐ ಟಚ್ ಹಿಯರ್, ಜಾಸ್ತಿ ಕರೆಂಟ್ ಆಗಬೇಕು. ಆಸ್ ಐ ಕೀಪ್ ಆನ್ ಪ್ಲೇಸಿಂಗ್ ಲೈಕ್ ದಿಸ್, ಕರೆಕ್ಟ್, as I keep on placing like this, the current will become more and more strong, powerful. So this milliampere, what this will do is microampere. What this will do is, even minute to minute current, it will identify and show how much current is passing through the circuit. Getting? So there are microamperes to tell about the chips, electron chips ಮಾಡ್ತೇವೆ, ಅಲ್ಲೆಲ್ಲ ಯೂಸ್ ಆಗ್ತೈತೆ. ಎಷ್ಟು ಕರೆಂಟ್ ಹೊಂಟೈತಪ್ಪ ಅದೆಲ್ಲ ಮೈಕ್ರೋ ಒಳಗೆ ಹೋಗ್ತೈತೆ, ವೆರಿ ವೆರಿ ಸ್ಮಾಲ್ ಕ್ವಾಂಟಿಟಿ. Example or mobile, getting something or some chips might use very very less amount of current, getting, so there this thing is used. ಅಲ್ಲಿ ಅಷ್ಟೇ ಕರೆಂಟ್ ಹೋಗ್ಬೇಕು, ಗೆಟಿಂಗ್ ಅವನು ಭಾಳ ಕಮ್ಮಿ ಕರೆಂಟ್ ಹೋಗ್ಬೇಕಲ್ಲಿ, ಜಾಸ್ತಿ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿ ದಮ್ ಅಂದ್ಬಿಡುತ್ತೆ ಮೊಬೈಲ್, ಗೆಟಿಂಗ್. ಸೊ ದಿಸ್ ಥಿಂಗ್ ಇಸ್ ಯೂಸ್ಡ್ ವೆರಿ very very less amount of water current is used. So to identify how much current is passing there, we use microampere. It will tell how much current is passing. Okay, read this once again.
Small quantities of current are expressed in milliampere.
So small quantities expressed in milliampere or in microampere. Read this next. Ammeter, that is an ammeter. And microampere is check ಮಾಡ್ತಿದ್ನಲ್ಲ, that's only the device is called as what, ammeter. Read.
Ammeter, an instrument to measure electric current in a circuit. It is always connected in a series of circuits.
So that is an ammeter. There are two types of ammeters. One is ampere, one is microampere. Microampere is kept in laboratories or any physics lab you go or any electrical lab you go. There you will find this microampere. Ampere means normal. Now how much we are using, that is an ampere. Getting 5 ampere, 8 ampere we might be using. So this will show properly, but this will show in milliampere. That means very very minute current if you are using and doing any experiment. If you go to any laboratories, think, will they give you direct ampere? ಈಗ ನೀ ಏನಾರ ಮಾಡತ್ತಿರಪ್ಪ, ನಿಮ್ಗೆ ಶಾಕ್ ಕೊಡೋ ಚಾನ್ಸಸ್ ಇರ್ತದೆ. ಹೇಳತ್ತಿದ್ರೆ 220 volts ನಾ ಕೊಟ್ಟು ನಿಮ್ಗೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ರಿ ಅಂತ ಕುಂದಿಸಿದೆ ಅಂದ್ರೆ, ಜಸ್ಟ್ ಥಿಂಕ್, 220 volts if I give and we start making experiment, if you make anything wrong, ದಮ್ ಅಂದ್ಬಿಡುತ್ತೆ, ಪೂರಾ ಸರ್ಕ್ಯೂಟ್ ಹಾರ್ಬಿಡುತ್ತೆ. ಸೊ ದೇ ಯೂಸ್ microamperes. ಅಂದ್ರೆ ನೀವು ಏನೋ ಟಚ್ ಮಾಡಿದ್ರು ಏನೂ ಆಗಿಲ್ಲ, there is no problem. Getting? So this device is called as ammeter. Two types of ammeters are there, microampere and ampere, and it should be connected in always what, a series. See, this is a regulating, ಇಲ್ಲಿ ಜಾಸ್ತಿ ಕಮ್ಮಿ ಮಾಡ್ಕೊಳ್ಳೋದಿರ್ತದೆ. This is positive terminal or negative. Here you can connect positive terminal. ಇಲ್ಲಿ black color ಇರ್ತೈತಿ, ಇಲ್ಲಿ red color. Okay, so here you can take negative, here you can take positive. ಇಲ್ಲಿ wire connect ಮಾಡೋದಿರ್ತೈತಿ, ಇಲ್ಲಿ wire ಹಾಕಿ ತಿರ್ಗಿಸೋದಿರ್ತೈತಿ. Okay, so here positive to negative ಹಿಂಗ್ ಕನೆಕ್ಟ್ ಮಾಡಿ ನೀವೆಲ್ಲರೂ ಇಲ್ಲಿ ಏನ್ರ ಅಟ್ಯಾಚ್ ಮಾಡ್ಬೋದು ಬಲ್ಬ್. ಇಲ್ಲ ಏನ್ರ you can take battery. If I place battery, it will tell how much this battery is giving current. ಈ ನನ್ನ ಬ್ಯಾಟ್ರಿನ ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ರೆ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್, it will tell how much current is flowing in that battery exactly. Getting? That is the work of ammeter. Ammeter is a device which shows how much current is passing. If it's in ampere, it will show in amperes. If it's in microampere, it will show microampere. Microampere is measured in micro. Okay, micros, and it is milliampere. Microampere, ampere is measured in what? Current is measured in ampere. And if it's less current, ಭಾಳ ಕಮ್ಮಿ ಕರೆಂಟ್ ಐತಪ್ಪ ಅಂದ್ರೆ milliampere. Milliampere. If you are using very, how I should write that? Small quantity of current. Small quantity, ಭಾಳ ಕಮ್ಮಿ quantity current ಯೂಸ್ ಮಾಡತ್ತಂದ್ರೆ it's measured in milliampere. Getting? Any doubts? Any doubts? Next page. Do one thing right here. Go back. Take. When you are writing, read that also. I will ask and start. ಇಲ್ಲಿ ತನಕ ಓದ್ಕೋರಿ ಕರೆಕ್ಟ್. All the definitions. Okay, what is electric current? Electric current.
passing of electrons.
ಏನು ಪಾಸಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೇಳ್ಬಿಟ್ರೆ
From positive to negative.
electric current.
Flow of electric charges through a conductor.
ತಿಳಿತೀನಿ ಸರಿ. ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಸರ್ಕ್ಯೂಟ್.
Continuous and closed path of an electric circuit is called.
ಹಾಂ
It's called.
ಸರಿ. ಕರೆಂಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫಾರ್ಮುಲಾ.
Q is equals to I by
ಕರೆಂಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು
current is equals to Q by
current is I is equal to Q by T. I is equal to Q by T. That's it. SI unit of current. SI unit of current. SI unit of current. SI unit of charge. ವರ್ಷ SI unit of charge. ನೋಡಿ ಹೇಳೋದಲ್ಲ. SI unit of charge. Coulomb. So it, most important question is SI unit of charge. Many times I have asked that question. Coulomb. Charge Coulomb. Okay. So keep reading properly. Next. Current is always I. Remember, current is I. Most important, we are learning electricity. Current is referred to I. Charge is Q. Current is a ampere, measured in ampere. Charge is measured in coulomb. Okay, very very basic. Next, read
Current of 0.5 ampere.
from the beginning. That you read first. No, first we'll do this. Okay, read. This is a sum. Okay, see a current of 0.5 ampere. So I current is equal to 0.5 ampere. Time is equal to 10 minutes. 10 minutes can be converted to 600 seconds. One thing I will do. Numerical sums one shot I will do at the end of the chapter. Once I complete the chapter, we will take full numericals because it will be easier. If I break and do it here, it will take more time. Okay, ಮತ್ತೆ ಅರ್ಧಂಬರ್ಧ ಎಲ್ಲ ಆನ್ಸರ್ ಬರ್ತಿದ್ದೈತಿ ಮಜಾ ಬರಂಗ. Once I will take questions, then we will do one shot. Numericals, examples plus exercise, one shot I will do. Okay, so numericals I will not take now. They are using which formula here? I is given, T is given, Q is equal to IT they are using, and they got the answer. Charge they are finding. Okay, leave. Next.
Flow of charges inside a wire. Inside a solid conductor, atoms are packed together, but electrons can easily travel through it, almost as if they are in a wire. When a current flows through a conductor, the electrons move with the average drift speed 1 millimeters per second of a typical copper wire. However, an electric bulb lights up as soon as the switch is turned on. It is not due to the movement of electrons of one terminal to the other terminal.
See here, now what will happen means if I take a copper wire, this is a copper wire, this is a cross section area of copper wire. As I turn the current on, so this is negative terminal, this is positive terminal, when we connect it to that, the electrons start drifting. The jagga start agudide one direction kade. See here is negative, here is positive. Okay, so they are drifting here. Think like that. Current pass agatati, the current is continuously drifting. Adar ಒಳಗಿನ electrons move agi what they are producing current. So how current is produced? They are produced by electrons. Electrons start drifting at one place. Getting push start ಆಗ್ಬಿಡ್ತದೆ. There is an energy. ಅದು ಹಿಡಿದು ನೋಡ್ರಿ ಮನೆಗೆ ಹೋಗಿ ಗೊತ್ತಾಗ್ತದೆ ಎನರ್ಜಿ ಹೆಂಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿ. Okay, getting over drift ಆಕೈತಿಲ್ಲ current ಹೊಡೆದ್ರೆ you feel that drift ಆಕೈತಿ ನಿಮ್ಮ ಒಳಗಡೆ start ಆಕೈತಿ feeling. So they start drifting at one place. Read this once again. From the beginning you read. When he is reading, understand that what he is saying. Okay, read.
Inside a solid conductor,
So inside a solid conductor, this is a copper wire. Inside that I'm saying, inside that
atoms are packed together.
atoms are packed together. If you take any solid, copper is solid. The elements, the atoms inside the atoms are the small units. They are packed tightly. Solids are packed tightly. Next.
But electrons can easily travel through it.
See, they are packed that much tightly, but also electrons will move very easily from that. Getting? Current will pass from it. ಅಷ್ಟು ಟೈಟ್ಲಿ ಪ್ಯಾಕ್ಡ್ ಇರ್ತದೆ ಆಕ್ಚುಲಿ ಏನು ಮೂವ್ಮೆಂಟ್ ಆಗಬಾರ್ದಲ್ಲಿ ಗೆಟಿಂಗ್ ಬಟ್ ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ವಾಟರ್ ಇಸ್ ಲಿಕ್ವಿಡ್ ಇಟ್ ಕ್ಯಾನ್ ಟ್ರಾವೆಲ್ ಎನಿಥಿಂಗ್ ಕ್ಯಾನ್ ಟ್ರಾವೆಲ್ ಈಸಿಲಿ ಬಟ್ ಇನ್ ಸಾಲಿಡ್ ಆಲ್ಸೋ ಕರೆಂಟ್ ಕ್ಯಾನ್ ಪಾಸ್ ಈಸಿಲಿ ಓಕೆ ಸೊ ಇಟ್ ವಿಲ್ ಡ್ರಿಫ್ಟ್ ವೆರಿ ಈಸಿಲಿ ನೆಕ್ಸ್ಟ್
Almost as if they are in
ಆಲ್ಮೋಸ್ಟ್ ಆಸ್ ಇಫ್ ದರ್ ಇನ್ ವ್ಯಾಕ್ಯೂಮ್ ಅದು ಹೆಂಗೆ ಟ್ರಾವೆಲ್ ಮಾಡತ್ತದ ಒಂದು ಕರೆಂಟ್ ಏನೂ ಇಲ್ಲ ಇಲ್ಲಪ್ಪ ಅಲ್ಲಿ ಖಾಲಿ ಸ್ಪೇಸ್ ವ್ಯಾಕ್ಯೂಮ್ ಮೀನ್ಸ್ ಖಾಲಿ ಸ್ಪೇಸ್ ಒಳಗೆ ಹೆಂಗೆ ಓಡ್ತೈತಲ್ಲ ಆ ಟೈಪ್ ಇಟ್ಸ್ ರನ್ನಿಂಗ್ ಇನ್ ದಟ್ ವಾಟರ್ ಪ್ಯಾಕ್ಡ್ ಆಟಮ್ಸ್ ಅಷ್ಟು ಟೈಟ್ ಐತದ ಆದ್ರೂ ಅಲ್ಲಿ ಅಷ್ಟು ಫಾಸ್ಟ್ ಡ್ರಿಫ್ಟ್ ಆಗತ್ತೆ ಕರೆಂಟ್ ದಟ್ ದೇ ಆರ್ ಸೇಯಿಂಗ್ ಗೆಟಿಂಗ್ ಫರ್ಕ್ ಬೀಳಂಗಿಲ್ಲ ಅದಕ್ಕೆ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಡ್ರಿಫ್ಟಿಂಗ್ ಸೋ ಫಾಸ್ಟ್ ದಟ್ ಇಟ್ ಇಸ್ ಲೈಕ್ ವ್ಯಾಕ್ಯೂಮ್ ಸ್ಪೇಸ್ ಅಷ್ಟು ಫಾಸ್ಟ್ ಡ್ರಿಫ್ಟ್ ಆಗ್ತದೆ ನೆಕ್ಸ್ಟ್
when a current flows through a conductor.
ಸೊ ವೆನ್ ಅ ಕರೆಂಟ್ ಫ್ಲೋಸ್ ಥ್ರೂ ದಿಸ್ ಕಂಡಕ್ಟರ್
The electrons move with the average drift speed,
Huh.
1 millimeter per second.
ಸೊ ದ ಡ್ರಿಫ್ಟ್ ಸ್ಪೀಡ್ ಇಸ್ ಆವರೇಜ್ ಅಂದ್ರೆ ಈಗ ಅದನ್ನ ಏನೋ ಒಂದು ಸಣ್ಣ ಇದ್ರಲ್ಲೇ ಹಿಡಿದು ಒಂದು ಲೋಡ್ ತಗೊಂಡ್ರು ಆವರೇಜ್ ಸ್ಪೀಡ್ ಇಸ್ 1 millimeter per second. So that much fast it is going. You can't imagine that. Okay, just bad that 1 millimeter per second. ಅದು ನಿಮಗೆ ಫೀಲ್ ಮಾಡ್ಸಕ್ಕೂ ಬರಂಗಿಲ್ಲ ಬಟ್ ಜಸ್ಟ್ ಥಿಂಕ್ ದಟ್ ಇಟ್ಸ್ ವೆರಿ ವೆರಿ ಫಾಸ್ಟ್ ಸಿಕ್ಕಾಪಟ್ಟೆ ಸ್ಪೀಡ್ ಆಯ್ತು ಹಿಂಗೆ ನಾ ಬಟನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಕರೆಕ್ಟ್ ಬರ್ತದಿಲ್ಲ in 5 minutes in button start ಮಾಡಿದ್ರೆ slowly getting so it's very quick if I start button current will pass ಇಲ್ಲೇ ಅಂತಲ್ಲ ಥ್ರೋಟ್ ಈಗ ಒಂದು ಇಲ್ಲಿ ನಾ ಬಟನ್ ಕ್ಲಿಕ್ ಮಾಡಿ ನಮ್ಮ ಮನೆ ಒಳಗೆ ನಾ ಬಲ್ಬ್ ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿದ್ರು ಇಫ್ ಐ ಕ್ಲಿಕ್ ಹಿಯರ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಗೆಟಿಂಗ್ ಆರ್ ಸೊ ಇಟ್ಸ್ ವೆರಿ ಕ್ವಿಕ್ current has a drift speed of 1 millimeter per second in copper wire. As you change the wires, the drift speed will change. In copper wire, the speed is maintained. If you take any other wire, the speed might vary. Okay, next.
However, an electric bulb lights up as soon as the switch is turned on.
So electric bulb will light up as soon as you start the switch, the bulb will start glowing. Okay.
It is not due to the movement of electron from one terminal to the other terminal toward another.
Next page you take. ಹಿಂದೆ ಬಾ ಏನು ಕೊಟ್ಟಿಲ್ಲ ಸೊ it is not due to the movement of an electron from one terminal to the other terminal through the bulb, but it's because of the drift speed. The speed of the current is very very fast. Getting so it will travel very very faster in any circuit you take. Any doubts? Any doubts? Okay. Still, this is a very basic. Once we enter into potential difference, then you will understand how current will pass. This is very very beginning. Okay. Next. Read.
Electric charges do not flow in a metallic conductor
Read.
by themselves. Here, gravity has no rule. Electrons move only if
There is a
there is a difference of electric pressure in conductor.
Banta. Now we have entered into the main concept, potential difference. See, potential difference is bada only idra meaning la potential difference means now the current should pass from one place to another place. Getting how it will flow from one place to another place. The power of flowing from one place to another place is only called as potential difference. Potential means the potential will like that's my potential. If I travel from here to there, I should have potential or not. From here I should pass there. And that this is the difference. I have traveled from here to there. You can think like that. Potential means from one place to another place. From here, point A to point B, current will pass. Current will pass from here to here. The potential difference means the passing of that current from point A to point B. Okay, read. Read further. Further illa see. Most in next page it is there. Read one side.
Electric charges do not flow in a metallic conductor by themselves. Here, gravity has no rule. Electrons move only if there is a difference of electric pressure in conductor. It is
So
not
electrons will move only if there is a difference, higher potential energy to lower potential energy. ಮುಂದೆ ಬರ್ತದೆ ಇನ್ನೂ ಹೇಳತ್ತಿಲ್ಲ ಅವ್ರು ನೆಕ್ಸ್ಟ್ read this.
the chemical action within a cell battery can generate the potential difference across the terminal of the cell, even when no current is drawn from it.
Read that once again. The chemical.
The chemical action within a cell or battery can generate the potential difference across the terminals of the cell, even when no current is drawn.
Next.
When the cell is connected to a conducting circuit, the potential difference sets them changes or
Charges.
in motion and produces an electric current. To maintain the current, the cell has to expand chemical energy stored in
Next page mostly full ಬರ್ತದೆ ಒಂದ್ಸಲ read.
the electric potential difference between 2 points in an electric circuit is the work done to move
Here it is, yes.
unit charge.
This should be in the beginning. This should be in the beginning. Then that should be there, that page. The electric potential difference, that means potential difference between 2 points, point A, point B. Between 2 points in an electric circuit, whichever electric circuit you take, the current should pass from one point to another point. The electric potential difference between 2 points in an electric circuit is a work done to move a unit charge from one point to another. So it's a work done to move a one unit charge from here to here. The work done to move the charge from one point to another point is only called as what? Potential difference. ತಿಳಿಯುತ್ತೆ? ಈಗ ಅಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ಒಂದು ಚಾರ್ಜ್ ಬಂತಪ್ಪ, ಅದು ವರ್ಕ್ ಮಾಡತ್ತಿಲ್ಲ, ಇಟ್ಸ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ ದೇರ್ ಟು ಹಿಯರ್. ದಟ್ ವರ್ಕ್ ಇಸ್ ಓನ್ಲಿ ಕಾಲ್ಡ್ as what? Potential difference. Getting? Potential difference means it's a work done to move a charge from one point to another point. It's very easy. Don't bad ಮಾಡ್ಬಿಡ್ತೀವಿ, ಮೀನಿಂಗ್ ತಿಳ್ಕೊಳ್ಳಿ. ಈಗ ವಿಚಾರ ಮಾಡಿರಪ್ಪ, ನಾವು ವಿ ಆರ್ ಗೆಟಿಂಗ್ ಕರೆಂಟ್ ಹಿಯರ್, ಬಟ್ ವೇರ್ ಇಟ್ ಇಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್? ಇಲ್ಲಿ ಬಾಜು ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದನ್ನ ವೇರ್ ಇಟ್ ಇಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್? ಎಲ್ಲ ಟರ್ಬೈನ್ ಎಲ್ಲರ ಹಾಕಿ ಬೇರೆ ಬೇರೆ ಸಿಟಿ ಒಳಗೆ ಆತ, ಬೇರೆ ಬೇರೆ ಸ್ಟೇಟ್ ಒಳಗೆ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿರ್ಬೋದು. ನ್ಯೂಕ್ಲಿಯರ್ ಪವರ್ ಪ್ಲಾಂಟ್ಸ್ ಆತ, thermal power plants. From there current is coming. So from there current should pass till here. Tilazil vichar madri. So that passing from point A to point B, one unit should pass from here to here. Loss ಆಗಬಾರ್ದು, ಮತ್ತೆ ಇಲ್ಲಿಂದ ಎಲ್ಲಿ ತನಕ ಹೊಂಟಿರಪ್ಪ ಲಾಸ್ ಆಗ್ಬಿಟ್ಟು ಹೋದ್ with a minimal loss ಆದ್ರೂ ಕಮ್ಮಿ ಲಾಸ್ ಆಗುತ್ತೆ, ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಬೇಕಾದ್ರೆ. So this is the most important concept, potential difference. Definitely they will ask potential difference. If you understand, you will understand Ohm's law. ಮುಂದೆ ನಾ ಏನೇನು ಹೇಳ್ತೇನಲ್ಲ ನಿಮಗೆ ಲಾಜಿಕ್ ತಿಳಕ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಮೀನಿಂಗ್. ಈಗ ನಿಮ್ಗೆ ಇದು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ತಿಳ್ಕೊಳ್ಳಿಲ್ಲಪ್ಪ ಮೀನಿಂಗ್ ಅಂದ್ರೆ ಮುಂದೆ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ವೆರಿ ಟಫ್, ವಿಲ್ ನಾಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಎನಿಥಿಂಗ್. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಮೀನ್ಸ್ the work done to flow a unit charge from one point to another point. One unit charge ಒಂದು ಪಾಯಿಂಟ್ ಹಿಡಿದು ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ತನಕ ಹೋಗಕ್ಕೆ ಏನು ಎನರ್ಜಿ ಬೇಕಪ್ಪ, ಏನು ವರ್ಕ್ ಮಾಡ್ತಿಲ್ಲ, ದಟ್ಸ್ ಓನ್ಲಿ ಕಾಲ್ಡ್ as potential difference. Potential difference SI unit is B. SI unit is ತಿಳ್ಕೊರಿ, ಏನು ತಿಳ್ಕೊರಿ, but it's B. Okay, B is equal to between 2 points work done, W work done by charge. V is equal to potential difference is equal to work done by charge. So how it is referred? See, potential difference ಅಂದ್ರೆ one point ಲೆ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಹೋಗ್ಬೇಕು, point A to point B. So it's work to be done. ವರ್ಕ್ ಮಾಡ್ಬೇಕಲ್ಲ, ಅದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ಹೋಗ್ಬೇಕು. ಯೂನಿಟ್ ಚಾರ್ಜ್ should pass from here to here and there is a time required here. So time. Q ಯಾಕೆ ಬರ್ದೇನ? W. Okay, W by time. I is equal to Q by T. That was it. Potential difference is equal to work done by time. If you don't remember this full definition, just remember this: potential difference is equal to work done by Q. Time ಬರ್ತೈತಿ, Q ತಗೊಂಡ charge. Work done to flow this charge. Okay, work done to flow this charge na time ತಗೊಂಡೆ. Time ಇಂದು ಬೇರೆ ಮುಂದ್ಗಡೆ mostly. I am taking a different formula. Potential difference V is equal to work done by charge passing at that time, like that I was writing. Charge will pass at one time or from point A to point B if it is passing. It will take time. So that time I was referring. But charge ಒಳಗೆ time include ಆಗೈತೆ ಅನ್ಸತ್ತೆ ನನ್ನ ಪ್ರಕಾರ. Okay. So potential difference is equal to work done by charge. Next.
SI unit of potential difference is Volta, named after Alessandro Volta.
So SI unit of potential difference is volts. ಇದು ಕೇಳಿರ್ಬೇಕು ನೀವು, ವೋಲ್ಟೇಜ್ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಬರತೈತಿ ಈಗ ಜಸ್ಟ್ ನಾ ಹೇಳಿದೆ. ಸೊ ವಾಟ್ ಎವರ್ ಡೊಮೆಸ್ಟಿಕ್ ಆರ್ ಎಲೆಕ್ಟ್ರಿಕ್ circuits we are using throughout India, it's 220 volts. India uses 220 volts. So 220 volts means that's a voltage power from ಅಲ್ಲಿಂದ ಇಲ್ಲಿ ತನಕ ಪಾಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ power that we are pushing is 220 volts. ಈಗ ಮನೆ ಒಳಗಾದ್ರೆ ಡೊಮೆಸ್ಟಿಕ್ ಆದ್ರೆ ಕಮರ್ಷಿಯಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್, ದಿಸ್ ಇಸ್ ಕಮರ್ಷಿಯಲ್ ಪ್ಲೇಸ್, ನಿಮ್ಮ ಮನಿ ಡೊಮೆಸ್ಟಿಕ್, ಅಲ್ಲೆಲ್ಲ ಎಷ್ಟು ಬರತ್ತೆ ಚಾರ್ಜ್? ದ ಪವರ್ is 220 volts. So the potential difference is voltage and it's named after Alessandro Volta. After him that is named. Any doubts? Volts. Potential difference SI unit is what? Volts. Now go back. Now read this.
Electric charges do not flow in a metallic conductor by themselves.
So ಈಗ ನಾ ಹಿಂಗಿಟ್ಟೆಪ್ಪ ಒಂದು think one metallic wire, if I keep it like this, if I connect battery, do you think that electric current, like we are connected by gravity, we are here because of gravity, ಇಲ್ಲ ನಾವು ಹಾರೋಗ್ಬಿಡ್ತೀವಿ, correct? So even electric current has any relation with gravity? Do you think that ಅಂದ್ರೆ ನಾ gravity ಹಿಂಗಿಟ್ಟೆ ಅಂದ್ರೆ gravity ಜೊತೆ current ಪಾಸ್ ಆಕೈತಿ? Is electric current related with gravity? That I'm asking. Do you think that? No, we are related with gravity. Gravity idra namge hidda hidistutte. Everything. See, this pen is also related with gravity. Is current directly related to gravity? No. Current will pass at its own pace. ಈಗ ನಾ ಹಿಂಗ್ wire ಹಿಂಗ್ ಮಾಡಿದ್ರೆ ಹಿಂಗೆ ಹೋಗ್ತೈತೆ. ಇಲ್ಲಿ gravity ಇಲ್ಲಿ ತಡಿ ಅಂತ ಹಿಂಗೆ ಹೋಗ್ತೈತೆ. If wire is like this, current will pass like this. So that they are saying. Electric charges do not flow in a metallic conductor or copper wire by themselves. ಹಿಂಗಿಟ್ಟೆ ಹಿಂಗ್ ಪಾಸ್ ಆಗ್ಬಿಡ್ತಿಲ್ಲ. That is not the case here. Here gravity has no role. So first point you should understand, gravity you cannot relate it with current. Current has its own pace, current will go at its own way. Wherever you will take wire, there will pass. Gravity ವಿಚಾರ ಮಾಡಂಗಿಲ್ಲ. ಇಲ್ಲಿ gravity ನಾ ಹಿಂಗ್ ಹೋಗ್ಬೇಕಪ್ಪ ಅಂದ್ರೆ ಹಿಂಗ ಹೋಗ್ತೈತೆ. Gravity ಇಲ್ಲ ಇದೆ ನಾ ಹಿಂಗ್ ಹೋಗ್ಬೇಕಂದ್ರೆ ಹೋಗಿಲ್ಲ. Getting how you will place your wire, there it will go. So gravity has no role in current, that they are saying. Next.
Electrons move only if there is a difference of electric pressure in a conductor. It is called potential difference.
Now to move and any electric charge, there should be a difference. ಇಲ್ಲಿ ತನಕ ಹೋಗ್ಬೇಕು point A to point B, then only it will move. ಇಷ್ಟ ಇಟ್ಬಿಟ್ಟೆ ಅಂದ್ರೆ ಇದ ಹೇಗಪ್ಪ, where it should move? Can it move anywhere? So electrons move from here to here. Electrons move only if there is a difference. This is the difference. Only if there is a difference of electric pressure in conductor, it is called as potential difference. So there should be a place to move. There should be the power to move. Then only it will move. Place of power illappa andre, potential illa andre, it will not move. ಈಗ ನೀವು ಎನರ್ಜಿ ನಾ ಬಲ್ಬ್ ನಾ ಸೆಲ್ ಕನೆಕ್ಟ್ ಮಾಡ್ಲಿಲ್ಲಪ್ಪ, ಬರೀ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಅಷ್ಟೇ ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಟ್ಟೆ, ಮೂವ್ ಆಗಿಲ್ಲ. ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಅಷ್ಟೇ ಕನೆಕ್ಟ್ ಮಾಡಿ, ಮೂವ್ ಆಗಿಲ್ಲ. Positive, negative, both you should connect, and there should be a space to move. Then it will move properly. That they are saying. Next.
The chemical action within a cell or battery can generate the potential difference.
So the chemical action in the battery. This is a battery which has some chemical action to do. So the current is passing. Getting? That is a switch where some chemical action is happening behind that. So current is moving. So the chemical action within a cell or battery can generate the potential difference. That is what is generating the potential difference, which is making the electrons move from one place to another place. In the terminal, across the terminals of the cell, even when no current is drawn from it. Any doubts? Any doubts? So everything is happening because of cell and battery, that they are saying it. Next.
When the cell is connected to a conducting circuit, potential difference sets the charges in motion and produces an electric current. To maintain this current, the cell has to expand chemical energy stored in it.
Once again, you read it.
When the cell is connected to a conducting circuit, the potential difference sets the charges in motion and produces an electric current. To maintain this current, the cell has to expand chemical.
So see, each and every cell, if I take, it will die one or the other day. How much energy it has, how much chemical energy it has, it is continuously taken away when it is connected in circuit. If I connect it, now currently I am using the circuit. So this battery runs for 8 hours. After 8 hours, if I use this battery, it will die. You know, I keep changing the batteries here. Because extra I add batteries. If this will die, I will take that. So when the cell is connected, now think this cell is connected. When the cell is connected to a conducting circuit, this is a conducting circuit happening here. The potential difference sets the charges in motion and produces an electric current. So potential difference is happening, you are hearing my voice, current is passing, everything is working fine. Potential difference is happening here. So it makes our work easier and our work is getting done here. To maintain this current, whatever is happening, the cell has to expand chemical energy stored in it. ಅದಕ್ಕೆ ನಾ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಕೆಮಿಕಲ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಮಾಡಿರ್ಬೇಕು. If continuously chemical energy is going, then only it will work. If it stops, chemical energy stop at one point, then what will happen? The energy will not be released. Band akitella work stop again. Then again, if I go home and charge it, this is a chargeable battery. If I charge again, the chemical energy will start producing. But chemical energy generate akati, then again we can use. So a cell should keep continuously producing what? Chemical energy. If it stops producing chemical energy, the polar circuit will break. That they're saying. Sami, mummy call kar. Okay. Read.
1 volt is the potential difference between 2 points in a current carrying conductor when a 1 joule of work is done. To move 1 coulomb
Okay, see here.
charge from
Potential difference we refer it as a volt. Yesterday we studied that. Potential difference means what? It's referred to that voltage. So potential difference. This is potential difference. Potential difference is how much? 1 volt. To move 1 volt from here to here. 1 volt, okay. So 1 volt is equal to what they're writing? 1 joule. Joule means what? Joule means work done or energy. Okay. Work done upon whole divided by 1 coulomb means charge. Yesterday we studied that charge. So what they're trying to say is 1 volt. If I need to move 1 volt from here to here, point A to point B, okay, 1 volt is equal to 1 joule. 1 joule means it's a work done to move this 1 volt from here to here. Correct? The work should be done or the work done to move 1 volt from here to here, or the charge to move here to here. Getting? The work done to move the charge is called as what? 1 volt. Getting? Read this sentence once again. Read it.
1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done. To move 1 coulomb charge from
1 joule. 1 joule of work done to move 1 coulomb of charge from one point to another point is only called as volt. Volt means potential difference. So the work done to move a charge from here to here is only called as what? Voltage or potential difference. Once again, train only ಹೇಳ್ತೀನಿ. Keep reading that. Okay. So the work done to move a charge from here to here is only called as what? Potential difference. That is only volt. That's so simple. The work done to move a charge. Charge is there. This charge should move from here to here. It should come till here. Okay, so the work done to move this charge from here to here is only called as volt or potential difference. Any doubts? So how do we write that? Potential difference means 1 volt voltage is equal to 1 joule. 1 joule of work is done to cover up what? 1 coulomb of charge. 1 coulomb of charge moves from there to there. Okay, that's only the work done. Any doubts? Okay, next. Now to measure how much work is done and how much charge is moved is called as volt. To measure this volt, we have a device called as voltmeter. This measures volt. This measures what? Voltage. ಈಗ ಇಲ್ಲಿ ಹೇಳಿದ ನಿನ್ನೆ ಇಲ್ಲಿ 220 volts ಬರ್ತದಪ್ಪ ಅಂತ ಹೇಳಿ ಆ ಟೈಪ್ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಬರತೈತಿ ಇಲ್ಲ. ಟು ಮೆಜರ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಅ ಡಿವೈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವೋಲ್ಟ್ಮೀಟರ್. ರೀಡ್.
Voltmeter. Instrument to measure potential difference. It is always connected to a parallel crossed points between which the potential difference is to be measured.
Okay, this is the instrument used to measure potential difference. That means how much work done, how much charge it is moving, how much it is doing work. That will understand here. Okay, so current is moving from there to here. I said potential difference is continuously happening. So to measure that potential difference, we have a device called as voltmeter. Voltmeter means directly it is equated to potential difference. If you remember that, it's okay. It's enough. Instrument to measure potential difference. Voltmeter. V. Potential means V. Difference means V. Instrument to measure potential difference. It is always connected in parallel. This you will understand in next class. Next class I will teach parallel series and what a unknown series birthday. So there are two types of series. So then you will understand what is parallel series. Okay, leave that. So it is always connected in parallel across points between which the potential difference is to be measured. At that time I will tell you how it is connected parallel and shown. Okay, any doubts? So potential difference means what? It is a work done to move a charge from one place to another place. That's only called as potential difference. It's a simple definition. And to measure potential difference, we have a device called as what? Voltmeter. So voltmeter is connected parallelly. If you connect it parallelly, you will get the answer. Any doubts? Okay, what is potential difference? According to you, what did you understood now? No,
Current passes through
Charge. Instead of current, say charge. Okay, because they are taking 1 joule of work done by 1 coulomb. Coulomb means charge. Okay, so a charge passing from one point to another point. The work done to move a charge. The work done to move a charge from one point to another point is called as what? Potential difference. Easy? Okay, the work done. First, you should say the work done. The work done to move a charge. There is a charge from here to there. I should say that movement is only called as what? Potential difference. Any doubts? Okay, next page. Take. Next page. So these are some components. This is a 1 mark question. Most of the question papers has this question. 1 mark definite question. So an electrical cell is represented as this symbol. So these symbols you should know, plus minus. A battery of combination of cells. That is a combination of cells. ನಿನ್ನೆ ಹೇಳಿದಲ್ಲ ಇಲ್ಲಿ ಬ್ಯಾಟ್ರಿ ಹಾಕೊಂಡು ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ಮೈನಸ್. ದಿಸ್ ಇಸ್ ಹೌ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಸೆಲ್ಸ್ ಆರ್ ದೇರ್. ಪ್ಲಗ್ ಕೀ. Okay, plug key switch closed means this is a closed, this is open. Closed ಇದ್ದಾಗ ಈ diagram ಮಾಡಬೇಕು, open ಇದ್ದಾಗ ಈ diagram ಮಾಡಬೇಕು. Getting? It's there in your textbook. A wire joint, a wire crossing without joining. Electrical bulb, a resistor of resistance R. Next, variable resistance rheostat. This will understand in next class. Next slides. Ammeter and voltmeter. Okay, what is ammeter? Ammeter. Ammeter, Ankit. Ammeter.
which measures charge.
Almost correct. Ammeter. Which measures current. Ammeter means current. Voltmeter means a potential difference. Getting or no? Ammeter under current measure ಮಾಡ್ತದೆ. How much current is passing. And voltmeter means it will measure potential difference. Any doubts? Okay. So these are the diagrams that you should understand. Practice that in home. Okay. Now ಕೊಡಂಗಿಲ್ಲ na? It's there in textbook. Most important. One question is fixed from this. Okay. Next. Okay. Read.
First law. Set up a circuit consisting of a
First, I will tell what is Ohm's law. See here. Ohm's law means he was a next page. So pass next page. Next. ಅದರಲ್ಲಿ ನಾ ಮಾಡಿ ಬೆಟರ್ ಅಲ್ಲೇ ಇತ್ತಲ್ಲ ಅದು ಪೀಸ್ ಅದು ಸೀದಾ ಮಾಡಬೇಕು. ಹಾಂ ಅಲ್ಲಿ ಫ್ರಂಟ್ ಬ್ಯಾಕ್ ಫ್ರಂಟ್ ನೆಕ್ಸ್ಟ್ ಪೇಜ್ ನೆಕ್ಸ್ಟ್ ಅನ್ನೋದೇ ನನಗೆ ಬ್ಯಾಕ್ ಉಂಟು. Next, so he was a George Simon Ohm. Okay, this guy was conducting experiment. When he was conducting experiment, go back. He saw that he took a circuit. He made a circuit which is considering of voltmeter, ammeter. This is closed now. Okay. So what he did? This is a circuit he has prepared. Now read. Go back. Now read.
set up a circuit of consisting of nichrome wire XY, 0.5 meter length, and an emitter, a voltmeter, and a 4-cell of 1.5 volt each. Nichrome is equal to an alloy of Ni, Cr, Mn, and Fe. Using one cell. Note the emitter reading I for the current and voltmeter reading
stop now.
for potential.
Stop. Okay. So see here, initially this diagram, this is not there. Okay, only it's like this. Plus, this is voltmeter V. Positive charge is coming here. That. Resistance X, Y. He has conducted this experiment. So what he did means first he has set up a circuit like this. Okay, where this is not there now. Initially this is not there. Okay. So how much charge here he is applying a cell? Cell should be placed here. How much voltage cell is placing? First initially 1.5 volt. So 1.5 volt cell I am placing it here. Okay, we are placing it here. Remember. This cell is 1.5 volt. When I connect this to 1.5 volt cell, here resistance. What is the meaning of resistance? First, I have not thought that only. So only I am asking. What is the meaning of resistance? Anybody knows here? Huh? Appliances. Afterwards, I will tell you. Next. Voltmeter is there here. Leave resistance now. So voltmeter, when the current comes here, when current is coming here, it should voltmeter will tell us how much voltage it is providing. And rest, difference voltmeter will be it keeps calculating. So voltmeter is giving how much answer? Potential difference is 1.5. The current I through ammeter. Okay. So voltmeter is 1.5. We are passing a current of 1.5 volts, and the nichrome wire current from the ammeter is 0.5 in the first stage. If I connect a 1.5 volt battery, powerfully this battery now connect the voltmeter is how much? 1.5 volts, and the ammeter is showing how much current in that battery? 0.5 ampere. Second time jasi martana. Okay, so current jasi this battery thodana, he will take 1.0 battery power is more no 1.0. If I take 1.0, this becomes 3 it seems. This became 3. Next time he took still more powerful battery. He took it 1.5. If he makes it 1.5, this will become how much of 4.5. Correct? Then he will take what? 2.0. If he takes 2.0, this will become 4.5, 5, 6, 6.0. If I take 2.5, how much will my answer? Can anyone tell me? 7.5. Getting what I am saying? So he did these connections. He took ammeter, he took voltmeter. He saw that how much if I pass 0.5 amperes of current, I am getting 1.5 volts. If I pass 1 ampere current, I am getting 3 volts. Don't you think that this and this are related? Relation is there or no? If this is increasing, this is also increasing perfect pattern. There is a pattern here. Pattern idilla. See here 0.5 means here 1.5. It double from 0.5 it became 1.0. This also doubled. From 1.5 this became 3. So there is a continuously increasing pattern in perfect manner. So he thought that there is a relation between current I and what the potential difference would. Getting? Afterwards, he has kept adding charges here ಇಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ಯಾನ ಓಕೆ ಬ್ಯಾಟ್ರೀಸ್ first 1.5 ಮತ್ತು 1.5 ಮತ್ತು 1.5 ಮತ್ತು 1.5 okay so he has kept adding charges like this was initial 2 batteries 3 batteries 4 batteries so as he keeps on increasing the batteries even the potential difference is keeping on increasing even ammeter is kept increasing in the same pace getting so he understood that there is definitely a relationship between current I and potential difference V. Okay, next page. Now what he did, he took out all the readings. After taking readings, now if you do 0.5 by 1.5, you will get what? Or 1.5 by 0.5 if you do V by I. They are doing V by I. First V is how much here? 1.5 V 1.5 by 0.5. If you do, you will get 3. 3.0 by 1 if you do, you will get a 3. V by I. 4.5 by 1.5 is correct. 1.5 if you do, you will get 3. He did V by I. However, this is proportional. He did V by I. He got this answer 3, 3, 3, 3. When I'm getting constant 3, that means there is a definitely what relation? There is relation. Then he plotted a graph. This is a VI graph. Potential difference V and a current I. This is potential difference V. This is current I. This is a VI graph. Very, very important. When he did a VI graph, he got the answer in like this way. He type one graph creator. So that shows there is a difference. There is a relationship between potential difference and current. Any doubts still here? Okay. Illu na hedida Ohm's law anta heli. So now we just know that there is a relationship between potential difference and current I. Any doubts still here? Go to next page. Now we will understand what he has done. Okay. Read.
In 1827, George Simon, Germany 1787, 1854, found a relationship between current and potential difference.
See, now we are understanding. So in 1787 to 1854 he was there. He found out relationship between current and potential difference. This is the most important thing. What did he do? His work was, he found out the relationship between current and potential difference. Just now we saw that. Notice how it was. So current is directly related to potential difference. Current is I, is directly proportional to potential difference V, voltage. That he found out by that experiment. Okay, next.
Potential difference.
Most important, now we are learning Ohm's law. Every question paper this will be there. Okay, now whatever he is reading, understand it properly. Read.
Across the end
From
of
beginning.
a metal, potential difference V. Across the end of a metallic wire is an electric circuit is directly proportional to the current flowing through it at constant temperature. It is called Ohm's law.
So he said, he gave a law. According to him, potential difference V across the ends of a metallic wire. Think this is a metallic wire from here to here. Point A, point B. Potential difference V across the ends of metallic wire in an electric circuit is directly proportional to the current I flowing through it at a constant temperature. That means V is directly proportional to I. How much energy will increase? How much potential difference? If you want more potential difference, your current should be at the higher pace. ನೀವು ಎಷ್ಟು ಜಾಸ್ತಿ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಮಾಡ್ತೀರಿ ಅಷ್ಟು ಜಾಸ್ತಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಬರ್ತದೆ. How? That's there in next slide. One second. Take next slide. Next slide. Back. ಇಲ್ಲೇ ಐತಿ. ಇದು R is equal to V by. First I will tell this, then I will take that. How ಅಂದ್ರೆ ನಿಮ್ಗೆ ಐಡಿಯಾ ಬರ್ತೈತಿ. First resistance ಅಂತ ಹೇಳಿಲ್ಲ ನಾನು. Read this.
R is a constant for the given metallic wire at a given temperature, and it is called its resistance.
See here. Now, if I take one wire, most important thing, if I take any wire, it will have resistance or no. Resistance means first point it's opposing speed. Resistance means oppose ಮಾಡ್ತೈತೆ current ಬಿಡಂಗಿಲ್ಲ ಒಳಗೆ. If current is coming, it will oppose all the metals, whichever metal you take, even we human beings. Current, if I directly induce current to my body, will my body take current wholly? Will it not oppose that current? Getting? There will be some resistance. Resistance means it's an opposing force. Stop ಮಾಡ್ತದೆ current. Getting? So what they are saying, R is a constant for the given metallic wire at a given temperature and is called as what? Resistance. So every metallic wire, whichever you take, every metallic wire has its own what? Resistance. So either resistance is andre, if every metal has resistance or if every body has resistance, so it's directly proportional to what? Now potential difference. ಈ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಕೆಲಸ ಏನಪ್ಪ ಫ್ರಮ್ ಎ ಟು ಬಿ ಹೋಗ್ಬೇಕು. ಈಗ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಪೋಸ್ ಮಾಡ್ತೈತಲ್ಲ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಕೀಪ್ಸ್ ಅಪೋಸಿಂಗ್ ದಟ್, it will not make it easier. Okay, next further you read.
According to Ohm's law, R is equal to V by I.
So he says that resistance is equal to potential difference upon current I. Resistance is equal to potential difference means it's a work done to move a charge from here to here, whole divided by current. So it's an opposing force. Okay, next.
If potential difference is 1 volt and the current is 1 ampere, then the resistance R of the conductor is 1 ohm.
So either resistance is, if it is 1 volt, sorry, potential difference is 1 volt and current is 1 ampere, then this will be 1 ohm. Resistance is written as ohms. If resistance under ತಿಳಿತ್ಲಾ, any doubts? Resistance means it's an opposing force. Okay, if current is passing, it will oppose that. So resistance is directly took as what? Ohm's law. How it is related means 1 ohm is equal to 1 volt by 1 ampere. 1 volt by 1 ampere. Go back now. Okay, now see here. Potential difference V across the ends of a metallic wire in an electric circuit is directly proportional to the current I flowing through it. Now, that only saying potential difference V is directly proportional to the current I in this metallic circuit where current is passing, and he is telling that what the temperature should be constant. In a temperature of a metal, if I keep increasing, if I keep decreasing, its resistance will increase or not? Vichar madri. Resistance is directly proportional to the heat that you give to the body or anything. Even metallic wire ಸಿಕ್ಕಾಪಟ್ಟೆ heat ಐತಪ್ಪ ಅಂದ್ರೆ current will pass easily. ಎಷ್ಟು cold ಆಕೈತಿ, ಡಿಪ್ರೆಸ್ ಹಾಕೊಂತ ಹೋಗ್ತೈತಲ್ಲ, the current resistance ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಗ್ತೈತಿ. So the temperature should be constant. Temperature ಅಂತ ಹೇಳ್ತಿದ್ಲ, heat temperature. So what is saying? Potential difference across the ends of a metallic wire in an electric circuit is directly proportional to the current I. ಇಷ್ಟೆಲ್ಲ ಹೇಳಕ್ ಬೇಡಪ್ಪ ಅಂದ್ರೆ you can directly tell potential difference is directly proportional to current I. Ashta, that is only called as what? Ohm's law. Such that the temperature should be constant. Any doubt? Ohm's law? Any doubts? Ohm's law? What is Ohm's law?
V is directly proportional to the I, in which the temperature should be constant.
Potential difference is directly proportional to the current I, such that temperature should be constant. That is called as what? Ohm's law. Any doubts? Sit. Any doubts? Ohm's law? ತಿಳಿತ ಏನ್ ಮಾಡಿದ ಅಂತ ಹೇಳಿ experiment. He took potential difference, he took current. He showed that there is a relationship between current and potential difference, that they both are related. They are directly proportional. ಇದು increase ಆತಂದ್ರೆ ಇದು increase ಆಕೈತಿ, ಇದು decrease ಆತಂದ್ರೆ ಇದು decrease ಆಕೈತಿ. That is the relation. So they both are directly proportional. Any doubts? Okay, next page. Go back 1 second. Here one formula is here. So he took V by I is equal to potential difference by current, if I take, that is directly proportional to resistance. Resistance R created. Next, V is equal to, if I send this I here, this is the formula, V is equal to IR. So we have three formulas of what? Ohm's law. Next. Go back. So see here. Praveen, you read.
A conductor having appreciable resistance is called a resistor. It is used to control electric current.
Now all the conductors, just now I was telling that only, resistance means what? All the conductors that I take, any metal you take, any body you take, wherever current will pass, the resistance will be there or no? Resistance means it will not allow the current to pass. If current is passing in this metallic wire, the whole current will not pass, there will be definitely some backing force. If current is passing like this is the opposing force. Opposing force. This opposing force is called as resistance. All the body, whichever body you take, some slight resistance will be definitely produced. Example, if I take too much resistance, if I take a plastic bottle or can I pass current in that? So its resistance is very, very high, peak. Current getting on like that you can think. So resistance means it is the opposite force of current. If current is coming, it will stop that, it will resist that. A conductor means where current can flow. A conductor having appreciable resistance is called a resistor. So a conductor having a appreciable resistance, all the conductors have some appreciable resistance, that is called as what? What a resistor. I think you guys might have seen these images in order with me. If you take any electric chips, electric boards, if you go to first year, so these are the resistors. These are there in remotes. These are there everywhere. What is their work? What is their work according to us? Why do we use resistors? Why do we use resistors? To avoid overflow. ಈಗ ನಾವು ಒಂದು ಶೆಲ್ ಹಾಕಿದೆಪ್ಪ, ಆ ಚಿಪ್ಪಿಗೆ ವಿಚಾರ ಮಾಡ್ರಿ, ಇಫ್ ಇಟ್ ನೀಡ್ಸ್ ಓನ್ಲಿ 0.5 ಆಂಪಿಯರ್ ಆಫ್ ಕರೆಂಟ್ ಟು ವರ್ಕ್, 0.5 ampere is sufficient for that. If I am giving 2 ampere of current for this chip, what will happen to that chip? What will happen? It will blast out. At this time, I must attach how many resistance here? I should attach 3. This is 0.5, 0.5, 0.5. Now 2 ampere became how much? 0.5 ampere. Resistors. These are the resistors. So resistor work is to oppose the current in the perfect manner. ಎಷ್ಟು ಕರೆಂಟ್ ಬೇಕಪ್ಪ ಅಷ್ಟೇ ಬಿಡಾಕ್ ಟ್ರೈ ಮಾಡ್ತಿದ್ರು. ಆಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ನೀಡ್ ಪರ್ಫೆಕ್ಟ್ ವಾಟರ್. ಈಗ ಇವೆಲ್ಲ ವರ್ಕ್ ಆಗತ್ತವ. ಸೊ ದೀಸ್ ಆರ್ ವರ್ಕಿಂಗ್ ಬಿಕಾಸ್ ದೇ ಆರ್ ಗೆಟಿಂಗ್ ಪರ್ಫೆಕ್ಟ್ ಕರೆಂಟ್. ಇದಕ್ಕೆ 2 amp ಇದಕ್ಕೆ ಇಲ್ಲಿ ಬಲ್ಬ್ ಇತ್ತು ಹೋಗೋದು. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ನೀಡ್ಸ್ 35 ಈಗ ನಂಗೆ ನೆನಪು ಬರೋದು 35 volts ಐತದ ಒಟ್ಟು. ಅಷ್ಟು ಬಂದ್ರೆ ಸಾಕದು ಕೆಲಸ ಮಾಡ್ತಿದ್. ಈಗ ನಾ ಅದಕ್ಕೆ ಸಿಕ್ಕಾಪಟ್ಟೆ 200, 300 ಸಿಕ್ಕಾಪಟ್ಟೆ ಕೊಡಾಗತ್ತಪ್ಪ. ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಟು ದಟ್? It will blast out. So there is a resistance required. Getting over for all electronic devices, even if you take mobile or if you take any laptop, resistors ಇರ್ತಾವ ಅದ್ರ ಒಳಗಡೆ. ಬಿಕಾಸ್ ಎಲ್ಲಾ ಕರೆಂಟ್ ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, ಯುಟಿಲೈಸ್ ಮಾಡಂಗಿಲ್ಲ. ಅದಕ್ಕೆ ಎಷ್ಟು ಬೇಕು ಅಷ್ಟು ತಗೋತೈತಿ. ಗೆಟಿಂಗ್ ಓವರ್. ಈಗ ನೀವು ಮೊಬೈಲ್ ಚಾರ್ಜ್ ಮಾಡ್ತೀರಿ, ಅದು ಚಾರ್ಜ್ ಮಾಡೋದು ಕಮ್ಮಿ ಮಾಡ್ತಿಲ್ಲ. ಚಾರ್ಜಿಂಗ್ ಮೀನ್ಸ್ ವಾಟ್? ಆಕ್ಚುಲಿ 220 volt ಬರ್ತಿರ್ತೀವಿ. Will your mobile take 220 volts? Just think. Why do they give that? ಚಾರ್ಜರ್ ಇಂದ ಇದಿರ್ತೈತಲ್ಲ, ಇದ್ರೊಳಗೆ ಏನಿರ್ತದೆ ಅಂತ ಮಾಡಿರಿ ನಾವು. ಓಕೆ, ಇದ್ರೊಳಗಡೆ ಅದೇ ದಿಸ್ ಇಸ್ ಅ 225 watt. ಹಿಯರ್ ಇಟ್ ಇಸ್ ರಿಟನ್. ಸೊ 22.5 watt. ಓಕೆ, ಇನ್ಪುಟ್ ಇಸ್ 100 to 240 volts. Here it is written, see, input is 100 to 240 volts. The output we are getting is 5 volts. That's the thing. Input is 100 to 240. So ನಮ್ಮ ಮನೆ ಒಳಗೆ 220 ಬರ್ತದೆ. ಸಾಕದು ಕೆಲಸ ಮಾಡ್ತೈತೆ. ಓಕೆ, ಬಟ್ ಔಟ್ಪುಟ್ is how much? Just 5 volts. So its work is to reduce the current or no? Getting? So that is only resistance. Resistance means a conductor having appreciable resistance is called as a resistor. It is used to control electric current. We are controlling the current here. Current flows at its own pace. ಅದಕ್ಕೆ ಸ್ಟಾಪ್ ಮಾಡಕ್ ಬರಂಗಿಲ್ಲ. ಈಗ ನಾ ಬೈಕ್ ಹೊಂಟೇನಪ್ಪ, ಬೈಕ್ ಹೊಡ್ಯಾತೇನೆ, ನಾ 100, 200 ಹೊಡ್ಯಾತ ವಿಚಾರ ಮಾಡಿರಿ. ನಮ್ ಗಾಡಿಗೆ ಬ್ರೇಕರ್ ಇಲ್ಲ ಅಂದ್ರೆ ಏನಾಕೈತಿ? ಪರಿಸ್ಥಿತಿ. You can just start, you cannot stop only or no. If there is no brake, we cannot stop. So think resistor as a brake. Current induce ಆಗ್ತಿರ್ತದಲ್ಲ, when current is flowing in this, it will break that. It will stop that opposing force. So that is how we use resistors. Any doubts? So resistors work like a brake in the current circuit. If current is flowing, if we need to break that, if we need to stop that, or if we need to ಕಮ್ಮಿನೂ ಮಾಡ್ಬೋದು, ಜಾಸ್ತಿನೂ ಮಾಡ್ಕೋಬಹುದು. ಓಕೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಹಾಕಲ್ಲ ಅಂದ್ರೆ ಜಾಸ್ತಿ ಆಕೈತಿ, ಹಾಕೊಂತ ಹೋಗ್ತೈತಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ರೀಡ್.
The current to a resistor is inversely proportional to.
Now you guys should tell me, this is current I, this is resistance R. Is it directly proportional, inversely proportional? Inversely proportional. Inversely proportional. Why it is inversely proportional? If I increase current, resistance will decrease. ಈಗ ಸಿಕ್ಕಾಪಟ್ಟೆ ಕರೆಂಟ್ ಬಿಟ್ಟೆ ಒಂದು ವೈರ್ ಒಳಗೆ, ಅದ್ರ ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೆಂಗೆ ತಿಳ್ಕೊಬೇಕು? ಗೆಟಿಂಗ್ ಆರ್ ನೋ? ಸೊ ರೆಸಿಸ್ಟೆನ್ಸ್ ವಿಲ್ ಡಿಕ್ರೀಸ್. ಇಫ್ ಐ ಇಂಡ್ಯೂಸ್ ಲೆಸ್ ಕರೆಂಟ್, ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ವಿಲ್ ಬಿ, ಸ್ವಲ್ಪ ಕರೆಂಟ್ ಬಿಟ್ಟಿದ್ರೆ ಏನಾಗ್ತೈತೆ? ರೆಸಿಸ್ಟೆನ್ಸ್ ಸಿಕ್ಕಾಪಟ್ಟೆ ಇರ್ತೈತೆ. ಇಫ್ ಕರೆಂಟ್ ಐ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ರೆಸಿಸ್ಟೆನ್ಸ್, ಇಫ್ ಕರೆಂಟ್ ಇಸ್ ಲೆಸ್, ದಿಸ್ ವಿಲ್ ಬಿ ಮೋರ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಕರೆಂಟ್ ಸಿಕ್ಕಾಪಟ್ಟೆ ಬಿಟ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಭಾಳ ಕಮ್ಮಿ ಇರ್ತದೆ, very very less resistance. If too much less amount of current you are inducing, then resistance will be high. If I take this battery, in head ತೋರಿಸಲ್ಲ battery, if I take it in hand, in ನಂಗೇನು ಫರಕ ಬೀಳಂಗಿಲ್ಲ ಅದು. ಅದಕ್ಕೆ current is very very minimal, my body resistance is very very high. Getting or no? ಅದನ್ನ 220 ವೋಲ್ಟ್ ಇದ್ರ ಇದು ಇಲ್ಲಿ ಒಂದು ವೈರ್ ಹಿಡ್ಕೊಂಡ್ರೆ ನಾಕೆ ಪರಿಸ್ಥಿತಿ ಕರೆಕ್ಟಾ? So that my body resistance is not that high now. The current is very very high, so current will pass through me. So the current is inversely proportional to the resistance. Any doubts? Any doubt? Okay, next. ಇಲ್ಲ ನೆಕ್ಸ್ಟ್ ಅಂದ್ರೆ ಇದಪ್ಪ ಎಲ್ಲದೀವನಿ ಈಗ ನೋಡ್ತಿರ್ಬೇಕಿಲ್ಲ ಏನ್ ಕೆಲಸ ಅದನ್ನ ಅಂತೇಳಿ. ಹಾ,
Component used to
ಇಲ್ಲಿ
regulate.
ಇದು ಓದ್ಪ.
If the resistance is doubled, the current gets half.
See here. If the resistance is doubled, if I double resistance, ಇಲ್ಲಿ ತೋರಿಸಿದೆನ resistance, how I keep doubling, the current will become half or ಕಮ್ಮಿ ಹಾಕೊಂತ ಹೋಗ್ತೈತಿಲ್ಲ ಕರೆಂಟ್. ಈಗ 3 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಐತಪ್ಪ, if I 3 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಐತಿ, if I increase resistance, this will become 1.5. ತಿಳಿತೈತಿ? ಜಾಸ್ತಿ ನಾ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮಾಡಿದ್ರೆ ಅದು ಅರ್ಧ ಹಾಕೊಂತ ಹೋಗ್ತೈತಿ. How much resistance you will increase, that much current will become less. How much current you will increase, like that resistance will become low. So if the resistance is doubled, current gets half, current will become half. If you increase the current, the resistance will become half. Getting? So that like that is a relation. It has many practical appliances. So it has too much practical appliances. You take any appliance, mixer, TV, fridge, ಎಲ್ಲರ ತೋರಿ, you will definitely find what resistors in that. There the resistors. Okay, next.
That complete one.
Study. ಇದು
A component used to regulate current without changing the voltage source is.
This is a rheostat. Rheostat is ದೊಡ್ಡ ಇರ್ತದೆ ಮಷಿನ್, ಅದು ಒಜ್ಜಿರ್ತದೆ ಭಾಳ ಸಿಕ್ಕಾಪಟ್ಟೆ. This you can see in first year or any practical lab physics. So that ಅದ್ರ ವರ್ಕ್ ಏನಪ್ಪ ಅಂದ್ರೆ, ಈಗ ನಾ ಎವ್ರಿ ಟೈಮ್ ಇಂಥ ರೆಸಿಸ್ಟರ್ಸ್ ಹೋಗಿ ಕುಂದ್ರಾಕ್ ಬರಂಗಿಲ್ಲ ಲ್ಯಾಬ್ರೋಟರೀಸ್ ಒಳಗೆ, ಇದು ಸಿಕ್ಕಾಪಟ್ಟೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಹೋಗಿ ಮುಂದಿರ್ಬೇಕಾಗ್ತದೆ. So they will directly give this. You can connect it to the circuit. You can keep resistor. ಈಗ ನಾವು 1.5 ಬೇಕಪ್ಪ, ಅಲ್ಲಿ ಇದು ಮೂವ್ಮೆಂಟ್ ಮಾಡೋದಿರ್ತದೆ, ಹಿಂಗೆ ಮೂವ್ ಮಾಡ್ಬೋದು. This we can move. As I move, I can, it starts from mostly 0.5, 1.5 ಹಂಗೆ ಡೈರೆಕ್ಟ್ಲಿ ನಾವು 1 ಗೆ ಇಟ್ಬಿಡ್ಬೋದು ಎಷ್ಟು ಬೇಕಷ್ಟು. ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ಒಂದೇ ರೆಸಿಸ್ಟರ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಅಪ್ಲೈ ಆಗ್ತದೆ. ಸೊ rheostat is a device which works like a resistor. ಎಲ್ಲ ಕೂಡಿಸಿ ಒಂದೇ ರೆಸಿಸ್ಟರ್ ಟೈಪ್ ಅದು. We can separate place ಮಾಡ್ಬೋದು, ಒಂದಸ್ಲ ಮಾಡ್ಬೋದು ಬ್ರೇಕ್. ಓಕೆ, a component used to regulate current without changing the voltage source is called a variable resistance. Rheostat is a variable resistor used to change resistance. Voltage ಏನು ಫರಕ್ ಬೀಳಂಗಿಲ್ಲ, resistance change ಆಗ್ತದೆ. Resistance you can make it higher or lower according to your need. Any doubts? Next please. Go back once again, we'll see whatever we read. So first, Ohm's law means what? Potential difference is directly proportional to current. how much potential difference will increase, that much current also will increase. If you decrease potential difference, current will also decrease. V is proportional to I, and V by I is equal to R, resistance. Okay, V is equal to IR. Next, then we have resistance or resistors. Resistor means it's the opposing force of current. If current is flowing, it will stop the current flow. Okay, and if you increase the current, resistance will become less. If you increase resistance, current will become less. Okay, so they are inversely proportional. They are inversely proportional. The current through resistor is inversely proportional to the resistance. Next, if you increase this resistance by 2 times, if you double the resistance, this will become half. If you increase current 2 times, this will become half. Okay. Last, rheostat is a device which is like a combined resistance. If I need to have one big resistance, I can use rheostat. So combination of resistors is only rheostat. You can think like that. One shot you can place any resistance you want. Any doubts? Any doubts? Next. First one, barometry is barrier itself, excellent. Take notes in there. Last one. Right. Okay, next. Take next. Read.
Certain circuit by connecting 4 dry cells of 1.5 volt each in series with the ammeter 0 to 5 range, leaving a gap of X and Y in the circuit. Complete the circuit by connecting it each row wire in the gap X, Y. Plug the key, note down the ammeter reading. Replace the each row wire with a torch bulb in the circuit and note down the ammeter reading. Repeat this with a 10-volt bulb and add many materials. The current is different from different components. It certain components, there
There is a flow of electric current while the other resistor flow.
Next page you take it.
Within a conductor,
Hmm.
electrons are not completely free to move due to the attraction of ions. So resistance is increased and motion of electrons is retarded. The component that conducts electricity and has a low resistance is called good conductor.
Hmm.
A component with high resistance is poor conductor. A component with very high resistance is called an
Go back. Now see here, they have took ammeter. Ammeter is a device which tells about the current, how much current is flowing, how much current is not flowing. It will tell us about the current. Now, it's very simple experiment. Here we are applying batteries. How many batteries? 3 batteries. 1, 2, 3, 4. 4 batteries here is applied here. Okay, battery. Here battery is there. This is a plug. Key on, key off. Switch on, switch off button. So here they have left some space. This is a wire ending XY. So first time when I take batteries and connect them and plug the key on, first time he has kept nichrome wire. First time he connected what? A nichrome wire. So when I connect nichrome wire, the current flowing through a nichrome wire will definitely will be same to this or it will change according to you guys. Will it be same? First you guessed it faster to it sub change current. It will definitely differ because nichrome wire has some resistance or resistance. All the wires have resistance. So self current in a change current will differ. Second time, if I use a 10 volt bulb, yes volt is 10 volt bulb. Again here, the ammeter reading will change. The ammeter reading will change. But current will change. Last they are using torch bulb, which is very huge. Bar dot bulb. Again the current will change. So this shows us that which type of device I am using, torch bulb torch which wire I am using, based on that the current is changing. ಅದರೊಳಗೆ ಎಷ್ಟು ಹೋಗಬೇಕಷ್ಟು ಕರೆಂಟ್ ಹೋಗ್ತಿರಂಗಿಲ್ಲ ಒಂದ್ಸಲ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಹೋಗ್ತಿರ್ಬೋದು ಇಲ್ಲ ಜಾಸ್ತಿ ಹೋಗ್ತಿರ್ಬೋದು. ಸೊ ಎಕ್ಸಾಕ್ಟ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಫ್ಲೋ. according to the devices you are using, the current will keep changing its pace. Clear? Because resistance is happening there. Next page you take. So they are telling us that a component that conducts electricity and has a low resistance itpa. A conductor which has low resistance, then this conductor is called as good conductor. Good conductor. Resistance is low. A component with a high resistance, current ಒಳಗ್ ಬಿಡಂಗೇ ಇಲ್ಲ. There is a resistance force high, so this is called as bad conductor. Good conductor means resistance should be low. Bad conductor means resistance should be high. Last, a component with high resistance is called as insulator. Insulator means current bidanga illa, very sikkapate, very high resistance is an insulator. Getting one example, according to heat I will give. Electricity ಅಂದ್ರೆ ನಿಮಗೆ ವಿಚಾರ ಬರಂಗಿಲ್ಲ ಒಂದ್ಸಲ. ಈಗ ಮನಿ ಒಳಗೆ ಫ್ಯಾನ್ ಯೂಸ್ ಮಾಡ್ತಿರಪ್ಪ, ಫ್ಯಾನ್ ಓಕೆ, ಅದು ಮೆಟಲ್ ಇಂದ ಇರ್ತೈತೆ ಒಳಗಡೆ, ಐರನ್ ಇಂದ ತವಾ, that will be hot, but the stick that you hold, will that be hot? That is opposing that heat or no? Heat ಐತೆ actually, ಆ heat ಹತ್ತಾತೈತೆ ನಿಮಗೆ, ಹತ್ತಾತಿಲ್ಲ, so that is resistance or no? Oppose ಮಾಡ್ತಿತ್ತು. So that only they are saying, ಆ type, it's an insulator. Insulator ಅಂದ್ರೆ which opposes that. Current ಹೊಂಟೈತಿ, current ಜಾಸ್ತಿ ಬಿಡಾತಿಲ್ಲಪ್ಪ ಅಂದ್ರೆ it's a bad conductor. If resistance is very high, it's a bad conductor. If resistance is low, it's a good conductor. ಈ current ಒಳಗೆ ಬಿಡಾನಕತ್ತಿಲ್ಪ ಅಂದ್ರೆ it's a insulator. Example, plastic, fiber ಆತ. These are insulators where current will not flow only, very high resistance. Any doubts? Okay, that they are saying. So go back now. So in this experiment we understood that if I keep changing these things, nichrome wire to torch bulb to 10-watt bulb, whatever I will change here, the current inducing will keep changing. The current will not be same through them. The current will definitely change. If 10 ampere current ಹೊಂಟೈತೆ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಕಮ್ಮಿ ಆಗ್ಬೋದು, ಅದು ಹೇಳತ್ತಾರ. ಸೇಮ್ ಹೋಗಂಗಿಲ್ಲ, ನೀವು ಹೆಂಗ್ ಚೇಂಜ್ ಮಾಡ್ತಿರಲ್ಲ ಆ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಕೈತೆ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ. Any doubts? Okay, next. Go next. ಈ ತಿಳಿತು 3 ಪಾಯಿಂಟ್ಸ್ ತಿಳಿತು. Okay, next. ಇದೊಂದು ಪಾಯಿಂಟ್ ಓದು, ಗೋ ಬ್ಯಾಕ್. Read, Praveen.
Within a conductor, electrons are not completely free to move due to the attraction of electrons. So resistance is increased and the motion of electrons is retarded.
So first only all the metals that they are tightly packed. First only the current cannot flow easily. That they are saying. Within a conductor, electrons are not completely free to move. The electrons hanga na bitte pa current odidu. It's not like that. The electrons are packed tightly. Electrons are not completely free to move due to the attraction by atoms. They are very tightly packed. They are very tightly packed to the attracted. So resistance is increased and motion of electrons is retarded. So what will happen? Resistance will be definitely increased only. ಅದಕ್ಕೆ ನೀವು ಪರ್ಫೆಕ್ಟ್ ಕರೆಂಟ್ ಬಿಡ್ಬೇಕು. ನಾ ಸ್ವಲ್ಪ ಕರೆಂಟ್ ಬಿಟ್ಟರೆ ವರ್ಕ್ ಆಗ್ತೈತೇನೆ ವಿಚಾರ ಮಾಡ್ರಿ. ನಾ ಜಾಸ್ತಿ ಕರೆಂಟ್ ಬಿಟ್ಟಾಗ ವರ್ಕ್ ಆಗ್ತಿರ್ತಾವ ಡಿವೈಸಸ್. ಈಗ ಇವೆಲ್ಲ ಎದಕ್ಕೆ ವರ್ಕ್ ಆಗತ್ತಪ್ಪ? ವಿ ಆರ್ ಲಿವಿಂಗ್ ಹೈ ಅಮೌಂಟ್ ಆಫ್ ಕರೆಂಟ್, ಸೊ ದೀಸ್ ಆರ್ ವರ್ಕಿಂಗ್. ಇಫ್ ವಿ ಗಿವ್ ಲೆಸ್ ಕರೆಂಟ್, 1 ಆಂಪಿಯರ್ ಕಮ್ಮಿ ಕರೆಂಟ್ ಕೊಡ್ರಿ, ವರ್ಕ್ ಆಗಲ್ಲ. ಗೆಟಿಂಗ್ ಓವರ್ ನೋ, ಬಿಕಾಸ್ ದಟ್ ಮಚ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರ್ತಾವ. ಸೊ ಎಕ್ಸಾಕ್ಟ್ ಅಮೌಂಟ್ ಆಫ್ ಕರೆಂಟ್ ಇಫ್ ಐ ಇಂಡ್ಯೂಸ್, ದೆನ್ ಓನ್ಲಿ ಇಟ್ ವಿಲ್ ಪಾಸ್ ಅಂಡ್ ಫ್ಲೋ ಅಂಡ್ ದೆನ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವರ್ಕಿಂಗ್. Getting or no? So they are telling us within a conductor, whichever conductor you take, nichrome wire yaad irtavare, electrons are not completely, they are tightly packed. Electrons are not completely free to move due to the attraction by atoms. So resistance is increased. Resistance is definitely there. To oppose that resistance, I will induce current, high amount of current. ಅವಾಗ ಏನಾಕೈತೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೊರಗೆ ಬಿಡಂಗಿಲ್ಲ, ಕರೆಂಟ್ ಪಾಸ್ ಆಕೈತೆ. So you take any conductor, resistance will be there only. ತಿಳಿಯತೈತಿ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಕಮ್ಮಿ ಅದ್ರೊಳಗೆ ಇರ್ತೈತಪ್ಪ ಕಾಪರ್ ಒಳಗೆ, ಸೊ ಓನ್ಲಿ ವಿ ಯೂಸ್ ಕಾಪರ್. ಇರ್ತೈತೆ ಅದ್ರಾಗ ರೆಸಿಸ್ಟೆನ್ಸ್, ಬಟ್ ವೆರಿ ಲೆಸ್, ಜಲ್ದಿ ಪಾಸ್ ಆಕೈತಿ. ಎನಿ ಡೌಟ್ಸ್? ನೆಕ್ಸ್ಟ್ ಪೇಜ್. Okay, here this is the most important thing. Read.
Ammeter reading in an electric circuit. nichrome wire of length L.
Hmm.
Assume the reading is equals to 1 ampere. Nichrome wire of twice the length 2L. Here the ammeter reading decreases to 1/2.
See here. ಇದೇನು ಮಾಸ ನೋಡಿ ಇಫ್ ನಿಕ್ರೋಮ್ ಲೆಂತ್ ಇಫ್ ಐ ಟೇಕ್ ದಿಸ್ ಮಚ್ 1 ಮೀಟರ್ ರೀಡಿಂಗ್ ತಗೊಂಡು ತಗೋರಿಪ್ಪ ಓಕೆ ದ ಕರೆಂಟ್ ವಿಲ್ ಫ್ಲೋ 1 ಆಂಪಿಯರ್ ಥಿಂಕ್ ಲೈಕ್ ದಟ್ if I take 1 meter nichrome wire the current is flowing how much 1 ampere if I increase this nichrome wire to 2 meter ಈ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಆಗ್ತಿಲ್ಲ ಲೆಂತ್ ಜಾಸ್ತಿ ಮಾಡಿದೆ this will become 0.5 ampere that they are saying so how much length you will increase how much length you will increase or how much cross section area the thickness will increase like that the current is shifting ಕಮ್ಮಿ ಹಾಕೊಂಡು ಹೊರಟೈತೆ ಈಗ ನಾ ಇದು ಕಮ್ಮಿ ಮಾಡಿದೆ ಅಂತ ತಿಳ್ಕೊರಿ 1 ಮೀಟರ್ ಇದ್ರೆ ನಾ 0.5 ಮಾಡಿದೆಪ್ಪ this will become 2 ampere so current is directly proportional to what this thickness or length inversely proportional okay ಇದು ಜಾಸ್ತಿ ಆತಂದ್ರೆ ಇದು ಕಮ್ಮಿ ಆಕೈತಿ ಇದು ಕಮ್ಮಿ ಆದ್ರೆ ಇದು ಜಾಸ್ತಿ ಆಕೈತಿ ತಿಳಿಯತೈತಿ that they are saying here next
A thicker, large cross section area. Nichrome wire of the same length L. Here, reading is
ಈಗ ನಾ ಇಲ್ಲಿ ಲೆಂತ್ ಬಗ್ಗೆ ಹೇಳಿನಿ ಥಿಕ್ನೆಸ್ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ಕರೆಂಟ್ ಕಮ್ಮಿ ಆಕೈತಿ ಫಸ್ಟಿಗೆ ಇಷ್ಟ ತೆಳ್ಳಂಗಿಪ್ಪ 1 ಆಂಪಿಯರ್ 1 ಮೀಟರ್ ಇರಲಿ ಎಷ್ಟಿರಲಿ ಥಿಕ್ ಇಫ್ ಐ ಇನ್ಕ್ರೀಸ್ 1 ಮೀಟರ್ ಇಟ್ ನಾ ಥಿಕ್ನೆಸ್ ಜಾಸ್ತಿ ಮಾಡಿದೆಪ್ಪ 1 meter is same but the thickness is increased then this will become half getting so either you can change the length or you can change the thickness cross section area to make the current change current okay next take next page I will tell everything one shot so the resistance of a conductor depends on its length first point length resistance how much more length you will take that much resistance will ಜಾಸ್ತಿ ಲೆಂತ್ ಮಾಡಿದ್ರೆ ನಾಕೆ resistance if I take too much length resistance will increase current will decrease length ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ resistance ಜಾಸ್ತಿ ಆಕೈತಿ similarly if I increase thickness second point its cross section area means thickness area pura ಜಾಸ್ತಿ ದಪ್ಪ ತಗೊಂಡೆಪ್ಪ wire what will happen resistance will again increase resistance will increase last nature of material most important the material should be better quality ಈಗ ನಾ ಎಂತ ಕ್ವಾಲಿಟಿ ಮೆಟೀರಿಯಲ್ ತಗೊಂಡಿದ್ರೆ ಕರೆಂಟ್ ವಿಲ್ ನಾಟ್ ಪಾಸ್ ಓನ್ಲಿ ಗೆಟಿಂಗ್ ಓವರ್ ನೋ ಇಫ್ ಐ ಟೇಕ್ ಅಲ್ಯೂಮಿನಿಯಂ ಇದ್ರ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿರಿ ನಾ ಅಲ್ಯೂಮಿನಿಯಂ ಓಕೆ ಕರೆಂಟ್ ಪಾಸ್ ಆಗ್ಬೋದು ಜಾಸ್ತಿ ಆಗಿಲ್ಲ ವೆರಿ ಲೆಸ್ ಅಮೌಂಟ್ ಆಫ್ ಕರೆಂಟ್ ಮೇ ಪಾಸ್ ಗೆಟಿಂಗ್ ಓವರ್ ನೋ ಇಫ್ ಐ ಟೇಕ್ ಕಾಪರ್ ಟೂ ಮಚ್ ವಿಲ್ ಪಾಸ್ so nature of material is very important which material you are choosing so resistance depends on these three factors any doubts length area of cross section nature of material ತಿಳಿತು ಮೂರು ಲೆಂತ್ ಜಾಸ್ತಿ ಇದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಇರ್ತೈತಿ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಇದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ನೇಚರ್ ಆಫ್ ಮಟೀರಿಯಲ್ ಯಾವ ಮಟೀರಿಯಲ್ ತಗೋದ್ರೆ ಅದ್ರ ಮೇಲೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಅಪ್ಲೈ ಆಗುತ್ತೆ ಎನಿ ಡೌಟ್ಸ್ ಟೇಕ್ ಇಟ್ ಇಷ್ಟ ಬರ್ಕೊಂಬಿಟ್ರೆ ಸಾಕು 3 ಪಾಯಿಂಟ್ಸ್